So that is the case. I have selected only G germanium. These halides, whatever addition of halides they are doing here, which gives the which hydrolysis atoms in the matters have been used to reduce the presence of hydraulic impurities in these glasses. It has been reported that these methods lead to better glasses. Just now, I said this transparency can be achieved by using the GE, the same thing. And the fluoride-based heavy metals glasses gain such interest material of fiber optics. Now, nowadays, the fiber optics also we are using it. So, by using a fluoride-based like NaF, is here represented in my topic, NaFKF, or in place of NaFKF, LiF, lithium fluoride also can be used. But already it has done, so I selected NaF and KF. Why this fluoride is necessary? Because it is giving a good result in the fiber optics, quantum electronics, and laser devices. This type of glasses are known to have a wide variety of physical and optical properties, such as high transparency from IR to UV, low glass transition temperature, low linear and non-linear low linear and non-linear refractive indexes, and low phonon energies and their potential as a host for the active rare earth ions. Now, before starting my topic, I use this NaF and KF. These are the halides. These are the alkaline halides, which can be used as a good modifiers to the modifiers in the glass system. This fluoride-based glasses like fluoroaluminate, zirconate, or fluorophosphate glasses. On their own, they don't have good glassy faces, but mixed, they contribute desirable properties. Mixed with the lithium borate and germanium oxide, we will get the good properties for it. My plant now, if it is planned to introduce NaF, KF as a glass modifier in lithium borate germanium glasses managed with the copper as a dopant. The role of glass modifier on the structural transformation in this plays a vital role, leading to some practical applications. Combination of these, just now I said NaF and KF combined with lithium borate glass with germanium, and dopant is copper. I am using here copper as a dopant. I am having in this, I want to get an application. A few papers I have researched and I got some application. I am thinking I will get the same application. The alkaline tetraborate glasses are common in materials of opto-optical electronics, non-linear devices for the frequency conversion in the ultraviolet region, and piezoelectric actuators. These are the applications I want to get in my whatever glass concept I have taken. By using my glass concept also, I want to get all these applications. Meanwhile, these glasses and their crystalline counterparts are considered to be good for the optically induced electro-opticity. Glasses have a wide scientific and industrial applications in the areas of electronic devices, optical filters, reflecting windows, ray observers, sensors, electro-optic devices, and sea lens. The glass containing alkali earth metals, heavy metal oxides, has applications in the field of optical communication, optical fibers, laser modes, optical filters, gamma rays, observers, photonic devices. These are only few applications I am getting. I may extend it. These are I am thinking I will also get with whatever glass I will prepare. All these applications I will achieve, and I will try to achieve it also. These are the literature survey whatever I have done. In this Telugu they have taken, and Br2O3 they have taken, ND3 I have taken. But my tellurium oxide, zinc oxide, titanium, VAF, RSO4, Na2B4O7, all this I have found, but whatever just now chemicals I am using like the sodium, potassium, our sir guided, and I said these are the very good if you use, you can achieve your applications. So now my aim is to prepare a sodium potassium chloride titanium tetraborate germanium glasses doped with transition metal ion. By making my glass, what I think to record XRD to confirm the amorphous nature of sample. Just now I said amorphous. In the beginning only I talked about this amorphous and crystalline, irregular or a regular pattern. Irregular pattern or amorphous engine. So that's the concept I want to confirm it. I want to record it by taking an example of by taking an experiment with XRD. Next, to study the physical properties like density, molar volume, refractive indexes, all these I want to study by my class. To study the spectroscopic properties such as optical absorption, EPR, and FTIR. This is the experimental procedure, not its status, but I am planning to do as guided. This is the experimental procedure I have to do it. Most commonly used experimental method is melt quenching method. It is easy and it is affordable. We can do it. Conventional melt quenching is simple and widely used for the preparation of glassy materials because of this all following reasons. First is glass preparation and handling are very easy. Speedy preparation of innumerable composition of glasses are possible. Simultaneously, both amorphous and crystalline natures can be obtained in the same moment. Large flexibility of composition and flexibility of geometry of a glass. These these are the problems. These I can do it easily by using the melt quenching method. So I am taking the melt quenching method to get my glass sample. Hence, melt quenching method I am using in this, and this is the flow chart how I will start my uh, uh, starting taking a sample and grind it, put it in a uh, 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 crucible and heat it up to 1050 degrees and then melt it and spread it uniformly and take that and leave it and after that I am going to transfer the three glasses. These are the composition. What very important point is the composition whatever we are using must be accurate. So these are the numeric our service provided may change. So whatever and sodium, lithium, germanium, copper, 10, 79, 10, 1, whatever numbers I have taken, just approximating. I will take this and I will do. If it is not formed with this, I may change like 965 like that. Altogether, I must achieve the 100% in this. So all this is mole percentage of whatever chemicals I am taking in the uh, taking to prepare my glass sample. So first one is by using the sodium NaF and second one I am using the KF. So these are the five references I have taken. I may do it with the 5, 10, 50. Whatever numbers I will get correct, I will put it in the next presentation. What work I have to carry out, just in the aim and in the report that I have given. The prepared classes will be investigated by the following experimental techniques. Optical absorption spectra to determine the optical band, gap and urban energy, etc. FTIR, Raman spectroscopy to determine the structural parameters. EPR spectra to determine the ground state bond parameters, environment around the transition metal ion, and influence of the surrounding lattice. My acknowledgement. My sincere thanks to our research guide, Professor Jitishwar Chakrapani ma'am, Head Department of Physics and Dean ma'am, and all faculty members of the Physics Department, and all my fellow research scholars of the Physics Department, and all the students present here, teaching and non-teaching staff. Thank you, ma'am. Yes, ma'am. But now we ordered some chemicals, ma'am. So after getting the chemicals, we will not complete, not it is not complete. So third is I needs to go to the other place and we have to do that. Just in hydrogen. And I will make that with yeah, some private college so that to visit. Yes, ma'am. Yes, ma'am. Yes, ma'am. Yes, ma'am. Yes, ma'am. Thank you, ma'am. Yes.
Then I'm doing literature survey of the society. First, before that, I'm going to express what is the objectives of my work. In this research work, we are going to develop, validate green synthetic methodology for the synthesis of new nitrogen heterocyclic compounds. And after synthesizing, we need to characterize the compounds. And the second objective is characterize the synthesized compound through advanced spectroscopic methods like UV, IR, mass, NMR, and some other chromatography techniques. Advanced chemical, advanced analytical techniques. And the third objective is synthesize nanomaterials. Here we are using a bottom-up approach. Bottom-up, for synthesizing a nanomaterial, we have several approaches. Top-down approach, bottom-up approach, and high-pressure approach. Several like method, soldier method. So that is depends on the material we are going to synthesize. That is depends on the material, starting material we are using. Here I am using a bottom-up method. Bottom-up method means a small molecule again constructed into aggregated particles in the nanometer. Okay, a molecule state is converted into nanometer. Such as nitrogen group, the nanometers are nitrogen group carbon dot. From the nitrogen heterocycle, which we have already synthesized in this one, and evaluated their morphology, optical, functional properties, and their application. This is the third aspect. And the fourth one, after synthesizing, characterizing all the heterocyclic compounds, we are going to assess the drug likeness. In our organic chemistry, everyone targeting synthesizing new compound and testing the molecule to be a drug. That is the hope for synthesis. Here also we are using the fourth objective. The synthesized drug is having the drug-like properties or not. Once the drug-like properties are having, there is having a therapeutic potential properties and protein that is active of the synthesized compound. Here further, we are using two methods. One is the in silico method and in vitro method. What I have given the words in the title. In silico method is combination. Here the several methods are there. One another combination we are highly reliable techniques, and also we can verify with another. Once we are taking the data from the one, then it will be compared with the another technique, like coding. After coding the result, the same result we can take the autograph or Swiss dynamic, like two we can do. Then we can assess the drug-likeness of the compound and the theoretical properties of the compound. After assessing this molecule, we need to validate by applying this molecule actual target. The fourth or fifth objective is applying the optimized result obtained in the in silico studies to assess the biological and pharmacological activity of synthetic compounds through the appropriate experimental studies. These experimental studies are in vitro. Okay. Generally, if the drug likeness is identified, we don't know the toxicity of the compound. We cannot directly do the in vitro. That's why we are going to choose in vitro. In vitro method means we are taking some cell line, extracting from the animal body, and we are applying this molecule on the cell line. Wherever the protein is there, on the exact protein, we are applying those molecules. Those molecules are binding to protein. Whether they are binding properly and whether it is showing any activity or not, we are binding. These are the five objectives in my research proposal work. Now, the structure of my proposal thesis. In the first chapter, the literature, introduction and literature story. And chapter 2 is a microwave aspect synthesis and a DFT characteristic. And in silico, EGFR, activity of substance 1,2 dihydro, 2 phenyl hydroxyl, 4,3 phenolene, 3 1 dihydro. And this is my thesis work detail. And when you come with your permission, I will say my some not the result and discussion, just my view. Yeah, in the 4 units, just I will show you. Okay, in the introduction, I have already told you, I choose the quinoline molecule. The quinoline molecule is very old and ancient molecule in the ancient from the Alexander time, when the Alexander was attacking India in a war, he suffered with the malaria. He was treated by our Indian people with the plant bark extract, that is Sigona bark. Okay, in the Sigona bark, that is the extract containing quinine. It is a natural product. That natural product is constructed with the quinine, some other substance. Okay, that is the first quinine molecule reported in the record. Later, some billions of compounds are synthesized. Today also, the very active work is going on the quinine. Why it is going on? When you see that this quinine derivatives are having anti-malarial activity and global ability, HIV, quinine molecules are not anti-prion, anti-prion property, and it can it is having quinine derivatives are having very binding, very active and binding ability to the other cells. Due to the reason I'm using this quinine molecule for developing the new endocyte. When you see the quinine molecule, only the rings are the scaffold. Once you are substituting with different substitutions, we can observe a different pocket. These pockets are called pharmacophore. Each pharmacophore is having one specific activity. When you see that from R1 to R7, we have almost 6 pockets are from the antifungal TB drug, antifungal, anticonvulsant, antitumor, anti-inflammatory, and again antifungal activity, and antibiotic and uh, antibacterial activity. And last two, seven and possibility, nitrogen possibility is the seven. So the research work is going on here, OED and luminary. And then once the drug molecule is considered to construct a new instrument, a new object. Now, this is the latest study. I have uh, taken recent research from that, the reported one. Some of the reported molecules I have chosen. In this, some of them are antibacterial compounds, some of them anti-cancer agents, some of them anti-fungal agents, antibacterial, and anti-fungal. All of them are not right. Okay, anti-fungal agents. CNS active, CNS is represents CNS active, central nervous system in stimulation and suppression. And other class. These are also molecules, specifically only cancer, anti-cancer. Very recently, the eighth molecule, below second. The recent molecule is reported in the list. That's why this molecule, due to the advantage of this molecule and scaffolding of this molecule, I have seen to construct or develop the several quinine based. Now, some other from old to new. The scope of pharmacological studies are quinine. The first one is quinine scaffold. We have substituted different substitutions from R1 to R7. We can develop the new quinine derivative. These quinine derivatives have the properties enhancing potency, very much important activity and efficiency, and reduce the resistance and tox. Suppose if you take an antibacterial drug, after some days or after some period, the molecule showing inefficiency to control the bacterial infection. Okay, that is called resistance. The resistance also here reduced. The improve the activity by improving the activity. Now I am targeting my molecules are I'm going to target actually anti-cancer agent. I am using 3 targets. One is the EGFR, and another one is the DNA glucoisomerase, and another last one is the DNR G quarterplex. These 3 targets are I have chosen. The first one is the purely and protein. The second one is the protein plus DNA, And the second one is the last one is the DNA doubly folded. That means in a DNA we have two strains of it. In general DNA we have two strains of it. Quadruplex is having four strains. Okay. Four helix structures are combined with the DNA. That's called DNA quadruplex. Okay. And this first of these three are the target to assess the regulatoriness and the anti-cancer activity by using the computational method. After assessing the computational method, I have chosen the in vitro method. Three cell lines I have chosen. The numbers are given H1975 is the lung cancer cell line, and MB468 is the breast cancer cell line, and HCC 827 is also lung cancer cell line. Once we assess these molecules' activity in the computational framework, we are optimizing these conditions and assess the optimized values. Those we can create the libraries. Suppose one phenolene we can take in billion ways, we can construct the billion molecules of library. From that, I'll collect only top 10 molecules. Those top 10 molecules can be synthesized. After synthesizing, we are assessing the activity. Those based on that activity, we are going to apply those molecules on cell line and identify the activity. Based on that, we are going to next step in vitro. But I have stopped at in vitro. Okay, because I am only mathematics student. I am not purely biology student. After that, I have learned and taken some support from the ISP and CCAP. I have collected those data and I'm ready to go. Okay. Now the present one. For synthesizing the molecules, new phenolene-based molecules. The first one, this is the first chapter. After the introduction of actual research work, micro assisted is DFT calculations and in silico EGFR inhibition activity studies of some 1,2 dimethyl 2-phenyl pyrazole 4,3 phenolene 3,1 derivative. In this synthesis, I have started to get a small molecule and aniline derivative. And aniline is substituted to some methyl methoxy, chlorine, like substitutes are there. That aniline derivatives are taken, that is methoxy inhibiting melanine, melanine. That leads to the I have named that aniline. That aniline is treated with the Dowden. The Dowden is the liquid solvent. The solvent boils at higher temperature. I needed to treat this. That's why I have chosen the Dowden. Then it is cyclate. The cyclate compound is phenolene. The phenolene is underway the automatic that is existing in 2 forms. Whenever it is treating it, okay. This is the scheme I have applied for the synthesis. Okay. After synthesizing, in silico state, this is the EGFR target. You see that there is a cancer cell liberated from the blue protein. That blue protein is always controlled, have a controlled mechanism to produce cells in the body. Whenever the epidermal growth factor, EGFR is epidermal growth factor receptor, that binded molecule is called epidermal growth factor. That is bind to that will synthesize the molecule by combining the NADPH to the DNA that leads to produce cell. Okay, that is a normal mechanism in the animals and the humans. But the EGFR is uncontrolled. Unwanted growth of cells leads to the cancer. Then for controlling the cancer or eliminating the cancer, we need to inhibit that receptor. Right. These molecules are applied. This is in a protein. That protein second. Okay, that is protein dominant in molecule. That's one molecule. Dominant to the exact protein in pocket, whatever the pocket is. Okay, the U-shaped pocket. That pocket is bind it. Now I have calculated quantum chemical energy calculation. This is very helpful to optimize the drug likeness and drug activity conditions. And this is the ADME study. We know that how we can take a drug, how it is absorbed, and like this. That is the experience. Okay. This is the third chapter. Let us tetracycline. Okay. Luminescent material in the last chapter. The study already completed. But I'm ready to give also procedure in so, okay. Thank you.
Sir, excuse me, sir. Sir, excuse me, sir. Which species you are taking, sir? Which species, particularly in species? Means
Actually, I am targeting cancer cell.
sir. Which?
Right.
No, you are taking the bark. Which species of particularly?
These are not the bark. These are the.
Which one, sir?
These are the electrostatic potential diagram distribution. There is electron distribution somewhere. It creates the polar nature, where it is creating the positive polar, where it is creating the negative polar.
Okay.
Depends on that molecule can bind the receptor or biological system. That shows the activity. To study that, we are creating, we are analyzing this diagram based on that where it is binding, where it is not binding.
Thank
you. Due to the binding nature. To assess the binding nature here. It is my plan of research. Acknowledge to picture the data point of the that is there with the university. Also, picture the data point of the and my guru, Professor K. Kondalagi, Department of Chemistry, University. Also my guru, that is president of Programming, and DRC of the Department of Chemistry, all faculty of chemistry. Thank you.
No, I request all the district colleges to start over. Since I think you all about clarity on the way. Right? So,
book लग रहे
change your work even after some time. But there won't be one chance before 1 year to change the type of work. Only once can be done, right? And I hope now I don't feel you will change your present work. We continue with the same work. So I request all the scholars to complete your work with this summer vacation. Okay, so that in that we can complete the part. Meanwhile, from the department, we can make yes. And all are really related. And I wish all the best. Thank you so much. So this question find from idea of expert మిమ్మల్ని కూడా జాయిన్ అయ్యారు ఫస్ట్ పార్ట్ వాళ్ళకి పోస్ట్ వర్క్స్ వాళ్ళ ఓన్ సబ్జెక్ట్ ఏరియాలో ఆ పోస్ట్ వర్క్ చదవాక ఎగ్జామ్ రాసారు అందరూ క్వాలిఫై అయ్యారు కాబట్టి now they have to start their work. They have to identify problems and then how to project the work. So for any reason, when you are chosen to work on some area, you have to search for the literature survey who has done this work before. There's so many done the same work, right? Find something new that you have not done before. So, అంతా కూడా చాలా మంది ఇదే వర్క్ చేస్తే ఉన్నప్పటికీ కూడా ఎక్కడైనా taking the materials to the playground, the material playground, component playground, compound between mixing of the between ఏదో ఒక వేరియేషన్ కొత్తగా system our start అది మనం మెన్షన్ చేయాలి so very people are balance work but my work is different from other work ఇక్కడ different మెన్షన్ తర్వాత టెక్నిక్స్ వాటర్ టెక్నిక్స్ you just just the problem okay what are the techniques you have to use ప్రాపర్టీ ప్రాపర్టీస్ తర్వాత ఏంటి ప్రాపర్టీస్ అని చెప్పాలి ఆ ప్రాపర్టీస్ చేయండి ఏమేమి ఎక్విప్మెంట్ వాడాలి ఏమేమి టెక్నిక్స్ వాడాలి ఇవన్నీ కూడా చదువుకోవాలి ఈజీగా అంటే ఈజీగా మనకు స్టడీ లాంగ్ అండ్ నాట్ చాలా ఆ నాలెడ్జ్ రావాలి చాలా అవన్నీ చదివి కొన్నిసార్లు చేసే వర్క్ వాళ్ళకి ఆ టెక్నిక్స్ రాకపోవచ్చు again they have said that the state that is expert ఇంట్రెస్ట్ టీచింగ్ చేసిన తర్వాత టీచర్ చేయడానికి కూడా ఒక ఎక్స్పోజర్ లాగా ఉంటుంది మనందరికి చూపించడం జరిగింది ఓకే అండ్ పని క్లాస్
స్ట్రైక్ లో ఫోటోస్ డిలీట్ చేసి
అందరూ సైన్స్ డిపార్ట్మెంట్ కదా సార్ మనం లేకుండా ఫోటో మనం